Hello, and welcome to Session 1, Understanding the Fundamentals of Cloud Computing. Today's focus is on how cloud computing has transformed the way we use technology, both personally and professionally. Let's explore this step by step so that by the end of the session, you'll understand not only what cloud computing is, but how it has reshaped the digital landscape through networking, virtualization, and data-driven innovation. This unit offers insights into computer networking essentials and cloud technologies. It covers their operating principles, protocols, and security considerations. Learners will explore hardware and software options for configuration and installation. Networking technologies like LAN and WAN will be examined. Protocol methodologies related to IP data networks are also explored. Cloud technologies include platforms like cloud applications and infrastructure. Their usage has surged due to various benefits. Models such as SaaS, PaaS, and IaaS offer different functionalities. Costs, configurations, and hybrid solutions vary. Major providers include Azure and Amazon Web Services. Cloud computing delivers services like storage and databases over the internet. Users access resources on demand without maintaining physical infrastructure. This model offers flexibility and cost efficiency. Organizations pay only for what they use. It's similar to a utility model like electricity. Cloud computing features on-demand self-service and broad network access. Resources are pooled to serve multiple clients securely. Rapid elasticity allows resources to scale up or down. Measured service ensures transparency in resource usage. These characteristics define the cloud model. Three main service models exist. IaaS, PaaS, and SaaS. IaaS offers virtual computing resources like servers. PaaS provides development tools and environments. SaaS delivers software applications over the internet. Each model serves different user needs and responsibilities. Cloud environments can be public, private, hybrid, or community-based. Public clouds are managed by third-party providers. Private clouds offer enhanced security for single organizations. Hybrid clouds combine public and private elements. Community clouds serve organizations with similar needs. Cloud computing offers cost efficiency by eliminating hardware purchases. Scalability allows quick resource adjustments. Accessibility enables work from anywhere. Reliability ensures data backup across data centers. Automatic updates simplify software management. Cloud computing faces security concerns like data breaches. Downtime depends on internet connectivity. Compliance with legal and regulatory requirements is crucial. Vendor lock-in can complicate switching providers. These challenges require careful consideration. Cloud-based storage services like Dropbox offer accessibility. Netflix uses cloud computing for global media streaming. Microsoft 365 provides cloud-hosted Office applications. These examples showcase cloud computing's versatility and reach. They highlight its impact on everyday technology use. Cloud computing evolved from developments in networking and virtualization. It began in the 1960s with concepts like public utility computing. The 1970s saw mainframe computers enabling resource sharing. The Internet's growth in the 1990s transformed the landscape. By the 2000s, cloud models expanded with major providers. IaaS offers control over virtual machines and storage. PaaS provides development tools without infrastructure management. SaaS delivers ready-to-use software applications. Each model has strengths and weaknesses. Organizations choose based on needs and expertise. Leading platforms include AWS, Microsoft Azure, and Google Cloud. AWS is known for reliability and service variety. Azure offers hybrid cloud capability and enterprise integration. Google Cloud excels in data analytics and innovation. Each platform suits different organizational needs. The client-server model is fundamental in cloud computing. Clients are end-user devices requesting services. Servers provide resources and data to clients. Clients focus on interaction, while servers handle processing. This relationship enables efficient cloud application delivery. Serverless computing allows application deployment without server management. It relies on cloud providers to handle infrastructure. Resources scale automatically based on demand. This model enhances cost efficiency and productivity. It's ideal for event-driven applications. Serverless computing reduces costs by charging only for compute time used. Traditional models require constant infrastructure running. The pay-per-use model eliminates idle resource costs. It's beneficial for applications with fluctuating workloads. Small businesses benefit from reduced operational expenses. Serverless platforms scale resources automatically based on demand. High traffic triggers additional resource provisioning. When demand drops, resources scale back. This ensures consistent performance without manual intervention. It's ideal for online ordering or data processing applications. Serverless computing eliminates infrastructure management tasks. Cloud providers handle server maintenance and security. Developers focus on writing and improving code. This leads to faster development cycles. It reduces maintenance costs and speeds up feature deployment. Serverless computing boosts developer productivity. Infrastructure abstraction speeds up innovation and updates. The modular design promotes microservices architecture. Organizations maintain smaller, manageable code bases. This enhances agility and development speed. Serverless computing contributes to energy efficiency. Resources are used only when needed. It simplifies disaster recovery and fault tolerance. Providers handle replication and failover. This model optimizes performance and cost for modern development. Serverless computing offers cost savings, scalability, and agility. It's valuable for organizations prioritizing flexibility. Event-driven applications benefit most from this model. It represents a natural evolution of cloud computing. Optimizing both performance and cost is its key advantage. Session summary and closing. In this session, we learned that cloud computing is transforming how organizations use technology. Its models and platforms offer flexible, scalable solutions to meet diverse needs. Finding the right balance between cost, performance, and control is crucial, and adopting cloud innovations is key to staying competitive in the digital era. In this session, we have learned that cloud computing continues to transform the way technology is used across organizations. Its various models and platforms provide flexible and scalable solutions to meet different business needs. Striking the right balance between cost, performance, and control is essential, as the most suitable approach depends on an organization's technical capability and strategic objectives. Embracing cloud innovations is no longer optional. It is vital for achieving efficiency, competitiveness, and long-term success in the digital era. Thank you for your attention today. If you have any questions, please feel free to contact us via WhatsApp at 07000 484,361,688. Thank you, and see you soon.